Welcome to this explainer. Today, we're diving into Chapter 8, specifically at pages 179 through 208, and looking at exactly how to build highly capable generative AI applications. How? By treating the LangChain framework like a modular assembly line. Look, if you're tired of treating AI like a magic black box, and you actually want to apply solid, structured software engineering to your LLM projects, well, you're in the exact right place.
Okay, let's take a quick look at the blueprint for our LangChain factory floor. We'll start with a welcome to the framework, then move on to the core machinery, processing your data, giving the AI memory, and finally, building tool calling agents. Let's step onto the floor.
Section 1. Welcome to the LangChain framework, the foundation. So here's the fundamental problem we face as developers, right? Isolated large language models are kind of like brilliant scholars locked in a windowless room. I mean, we know they have massive general knowledge, but they can't naturally interact with your company's proprietary database or your live APIs. That's exactly where LangChain comes in. It acts as the connective tissue. It's the framework that literally opens the door, allowing these models to shake hands with external data and specialized tools to build truly powerful, context-aware applications.
Moving right along to Section 2, the core machinery, models, templates, and parsers.
If LangChain is an assembly line, these next three components are the very first conveyor belt. We start with our engine, which is a model, say OpenAI super efficient GPT-4o Mini. But, an engine just running wild isn't very useful on a production line. So we combine it with structured instructions, which we call prompt templates. And finally, because we're building software that absolutely needs reliable data, we cap the whole thing off with output parsers to control the formatting. Let's look a little closer at those instructions.
Notice the difference here between just dumping an unpredictable raw prompt into a funnel versus actually using structured gears. If you pass a raw paragraph to an AI, you're going to get a total wildcard response back. But a prompt template? That is dynamic software engineering. It uses placeholders, like the word input wrapped in curly braces, to systematically guide the AI. Imagine you're building a project assistant. The template dictates the assistant's persona, while that input placeholder swaps in the specific user query right at runtime. It's clean, it's reusable, and it's totally predictable.
To finish up the core machinery, output parsers act as our quality control press. Have you ever asked an AI for a list and it arbitrarily decides to give you bullet points one day and then a comma-separated paragraph the next? Yeah, that's an absolute nightmare for software to parse. Output parsers force the AI's raw text into perfectly formatted structures. A really great example from Chapter 8 is enforcing a grid format using a command like table format equals grid. This takes all that messy conversational output and translates it into a rigid, clean table that your application's front end can effortlessly display to a user.
Section 3. Processing your data. Loaders and splitters. Okay, but our engine needs fuel, right? The most perfectly formatted output is totally useless if the AI has no idea what it's talking about. So LangChain digests your raw data in a two-step procedure that actually mimics a biological digestive system. You can't just shove a massive 500-page PDF down an LLM's throat. You have to ingest it and then break it down into smaller nutrients the model can actually absorb. In step 1, document loaders act as the physical hands grabbing the raw text from your external data sources. Whether it's an HTML web page, some massive internal company wiki, or just a folder full of plain text documents, the document loader's job is simply to fetch that raw material and bring it safely onto the factory floor.
Now, as developers, we all know the absolute pain of hitting an AI's limited context window. Feed it too much text at once, and it either drops important information or just flat out errors out. So in step 2, text splitters precisely chop those massive documents down into manageable pieces, or chunks, without losing their core meaning. They make sure that sentences and paragraphs actually stay together logically, so when the AI reads the chunk, it still makes perfect sense.
All right, Section 4, giving the AI memory, avoiding amnesia. As our data moves down the line, we've got to solve a major flaw in default language models. They completely lack inherent state. They essentially suffer from total amnesia after every single prompt. Think about it. If you ask a question and then ask a follow-up, the default model has absolutely no idea what you just talked about 2 seconds ago. LangChain fixes this by introducing memory components. Tools like conversation buffer memory act as a running transcript. They remember the conversation history across multiple steps and seamlessly pass that context back into the prompt template so the AI actually feels like it's having one continuous, highly intelligent conversation.
And that brings us to Section 5, Building Tool Calling Agents, the Autonomous Worker.
This is the most advanced station on the line.
We've built the foundation, processed the data, formatted the outputs, and added memory. But a chatbot still just sits there waiting for you to talk to it. So how do we give this passive machinery the power to act autonomously and actually do the work for us? Well, before we unleash our AI to make its own decisions, we need to apply a really vital technical tip straight out of Chapter 8, setting the model's temperature to 0. See, temperature controls creativity. A high temperature is great if you want it to write a poem, but terrible for writing code or taking automated actions. Setting it to 0 eliminates all that chaotic randomness and ensures our autonomous worker makes highly deterministic, repeatable decisions. We want to hire a strict accountant here, not an improv artist.
This strict logic is exactly what unlocks agents. Agents are autonomous workers within LangChain that don't just blindly guess at answers. They use step-by-step reasoning frameworks, like REACT, which stands for Reasoning and Acting, to figure out exactly what actions to take to solve a problem. If you ask an agent a complex question, it actually formulates a plan, looks at the tools you've given it, and decides which tool to use and in what order to get the job done.
So the crucial takeaway here is that by upgrading to a tool calling Agent, our AI can finally break out of its static data constraints. We can hand it a tool like DuckDuckGo's search results, and suddenly the AI can actively search the live web. It can look up real-time weather, fetch live project documentation, check current stock prices, parse that live data, and deliver a final actionable answer right back to you. It's no longer just thinking, it is doing. We've laid out the entire factory floor, from isolated models suffering from amnesia to a fully integrated, memory-equipped, autonomous agent actively using live tools. The only question left to ask yourself is, now that you have the blueprints to this AI assembly line, what kind of autonomous worker are you going to build today? Thanks so much for joining me for this explainer, and I absolutely cannot wait to see what you engineer.